All right, so taking a look here at questions 40 and 41, we are still factoring the polynomial completely. And number 40, we've been given the quantity h plus k squared minus 64. All right, so question 1, is there a GCF here? Well, I don't see one, so question 2, how many terms are there? Well, I see 1 and I see 2, so I should be thinking either difference of perfect squares or the sum and or difference of cubes. Well, let's see, I have a 2 here, a square, and I have 64, which is a perfect square, so I'm thinking this is a perfect square, but take a look here. We have a quantity that's being squared. We have this h plus k being squared, so this is going to be a u substitution. And let's go ahead and let u represent this quantity. And so now if we say that u equals the quantity h plus k, we can go ahead and rewrite this binomial here as now u squared minus 64. And if we were just given u squared minus 64, well, now we know that we're going to split this up into two binomials. If we're working with u, we're going to put u at the beginning, and we know the square root of 64 is 8. And we know with perfect squares, difference of perfect squares, we just do plus minus. And ordinarily, we could call it a day here. This would be where we could circle our answer and be done. But because we are using u substitution, we're saying u represents something. Well, now we have to go back and replace our u with what u represents. So here in this first factor, when we replace u with our h plus k, we're going to have h plus k and now plus 8. And here in factor 2, let's replace u. And so we have h plus k and now minus 8. And now we can go ahead and say that we've factored number 40. And these are h's, right? All right, so there's number 40. Let's take a look here at 41. And we've been given 49 minus the quantity r plus 2t squared. All right, let's run through it. Number 1, is there a GCF present? I don't see one. So question number 2, how many terms are there? Well, 1 term, 2 terms. So I should be thinking difference of perfect squares or the sum and difference of cubes. And I see 49. Well, hopefully 49 is ringing some bells in our minds, right? 49 is a perfect square. We have some quantity being squared, and we're subtracting. So this is a difference of perfect squares, except just like number 40, let's go ahead and use u substitution to represent this quantity being squared. And so let's go ahead and let u equal r plus 2t, this quantity here. And so now if we rewrite the expression that we were given, we have 49 minus now u squared. And if we were given this just right off the bat, we know that we can go ahead and right away go ahead and create 2 empty sets of parentheses. We know the square root of 49 is 7. We know that with the difference of perfect squares, one will be plus, one will be minus. And now we're going to go ahead and split this u up. All right, and ordinarily, this is the step where we would circle and be done. But again, because this is a u substitution, we have to go back and now replace the u in each of these factors with what we said u represents. So here in factor 1, we have 7 plus, and now r plus 2t. And here in factor 2, we have 7 minus r plus 2t. And let's go ahead and clean this up a little bit. So we have 7. And now if we distribute this, really plus 1, this positive 1, nothing is going to change as far as the signs, right? Because positive 1 times r is still positive r. Positive 1 times 2t is still plus 2t. But here in this second factor, we'll have 7. But now when we distribute this negative through, what's going to happen? Well, the signs are going to change, right? So we have 7, and now negative 1 times r is that negative r. Negative times 2t is now minus 2t. And now we have the factored form of number 41. All right, so again, these are still difference of perfect squares. Just realize that instead of being given a perfect square number like 36 or 25 or 81 or 100, now we've been given a quantity that we're going to let u represent that quantity. You will factor it just like you would normally a difference of perfect squares, and then your last step should be replacing the u or whatever variable you use to substitute. That last step will be replacing the original quantity that you let your representative substitute variable represent. All right, so 40, 41, done. Let's go ahead and take a look at 42 and 43. I'll see you there.